When the B-52 Stratofortress first took flight in 1952, few could have predicted that this iconic bomber would not only survive the Cold War, but would remain a powerful symbol of strategic air power even into the 21st century. Now, over 70 years later, the B-52 is still flying high, and it's undergoing a major modernization that will ensure its effectiveness for decades to come. From its humble beginnings as a turboprop project to becoming one of the most enduring heavy bombers in history, the B-52 story is one of power, innovation, and sheer longevity. The Cold War origins of the B-52. Like so many legendary aircraft, the B-52's creation was driven by the geopolitical tensions of its time. In the aftermath of World War II, the United States was locked in an arms race with the Soviet Union, and the need for advanced bombers capable of delivering nuclear weapons was more urgent than ever. By this point, Boeing had already established itself as a household name in military aviation, thanks to the success of the B-17 Flying Fortress during the war. In November 1945, as the B-29 Superfortress rolled off Boeing's assembly lines, the U.S. Air Force presented new requirements for a next-generation bomber. These specifications demanded an aircraft capable of carrying a crew of 5 or more, armed with a nuclear payload and able to fly at high altitudes with speeds exceeding 300 miles per hour. As the list of requirements expanded to include a range of 12,000 miles and the ability to deliver heavy nuclear munitions, Boeing was called upon to answer the challenge. The battle of engines, turboprops versus turbojets. One of the key points of contention in the B-52's development was the choice of engine. The U.S. Air Force was torn between using turboprop engines, which were seen as more fuel-efficient, or jet engines, which offer higher speeds but at the cost of greater fuel consumption. The argument was fierce, with some officials arguing in favor of turboprops, while others pushed for the more powerful turbojet engines. After much debate, the decision was made to test both options. Boeing engineers set to work on a prototype, and the first B-52 aircraft, known as the 46,440, was fitted with turboprop engines. This intermediate stage design wasn't perfect, and the generals continued to argue over the merits of turboprops versus jets. But eventually, it became clear that the future lay with turbojets, and the B-52 would soon take flight with a sleek new design. The creation of the B-52, engineering genius. In the early stages of the B-52's design, a group of Boeing engineers led by the likes of George S. Scherer, Bob Whittington, and Ed Wells set out to create a working prototype in what can only be described as garage style. Operating out of the Van Cleve Hotel in Dayton, Ohio, they crafted a balsa-wood model of the aircraft's basic shape. With a design that featured a 35-degree swept wing, 8 engines mounted under the wings, and bicycle-style landing gear, the B-52 prototype began to take shape. Though it was a makeshift design, it quickly captured the attention of the U.S. military, and the Stratofortress was born. By April 1952, the first B-52 prototype took to the skies, and just 3 years later, the bomber was entering service with the 93rd Heavy Bombardment Wing at Castle Air Force Base in California. With an impressive range and speed, the B-52 became an immediate success, setting numerous records, including the first non-stop flight around the world by a jet-powered aircraft. The B-52's record-breaking missions. As if it wasn't enough to be one of the most advanced bombers of its time, the B-52 also earned a reputation for setting world records. In 1957, a squadron of B-52s flew at an average speed of 525 miles per hour and completed a record-breaking non-stop flight around the world in just 45 hours and 19 minutes. But that was just the beginning. In the years that followed, the B-52 set other remarkable records, including the longest non-stop flight by a jet aircraft 12,532 miles from Cadena Air Base in Okinawa to Torrejon Air Base in Spain. It was clear that this bomber was a true marvel of aviation engineering, capable of both incredible endurance and the firepower needed to deter potential adversaries. The evolution of the B-52, from turbojets to turbofans. The first major update to the B-52 came in the form of the B-52H, which emerged as a derivative of the B-52G. While the airframe remained largely unchanged, the new model featured more advanced Pratt and Whitney TF-33 turbofan engines, which offered better fuel economy and performance. These engines increased the B-52's top speed to 650 miles per hour and its range to 8,800 miles without refueling, further solidifying the bomber's position as one of the most effective heavy bombers in history. The B-52H also saw upgrades to its armament, including the addition of a new tail turret with a 20mm M61A1 Vulcan rotary cannon and advanced avionics for low-altitude operations. These updates made the B-52 more versatile and able to operate in a broader range of combat scenarios. The modern-day B-52, still going strong. Despite the B-52's age, the U.S. Air Force continues to rely on it as a critical part of its strategic bomber fleet. The B-52 has been integral to numerous missions, including the Gulf War, Operation Iraqi Freedom, and the war in Afghanistan. Its ability to carry a heavy payload, fly long distances, and strike targets with precision has made it a valuable asset in both conventional and nuclear operations. The B-52's impressive mission readiness rate, 80.5%, is a testament to its continued reliability. Even as newer bombers, such as the B-1 Lancer and the B-2 Spirit, entered service, the B-52 remained the workhorse of the U.S. Air Force's bomber fleet. Its adaptability and low cost compared to newer aircraft have ensured its continued relevance in modern warfare. A new era, re-engining and modernization. In 2020, the U.S. Air Force issued a request for proposals to replace the aging engines of the B-52 with more modern, fuel-efficient engines. After a competitive bidding process, General Electric, Pratt & Whitney, and Rolls-Royce all submitted proposals, with Rolls-Royce's F-130 engine being selected as the winner. This new engine will not only improve the bomber's fuel efficiency, but also extend its service life for many years to come. In addition to new engines, the B-52 will undergo other significant upgrades, including the installation of a new radar system. The APG-79B4ASA radar, which replaces older mechanically scanned arrays, will improve the B-52's radar range, accuracy, and resistance to enemy countermeasures. This will ensure that the bomber remains a formidable threat in modern combat. The B-52's nuclear legacy. One of the most significant aspects of the B-52's history is its role in the U.S. nuclear arsenal. Since the 1970s, the B-52 has been capable of carrying nuclear weapons, and despite several efforts to strip it of this capability, the bomber's nuclear role has persisted. In 2024, there were talks of reintroducing the B-52's nuclear capability, with plans to equip at least 30 of the 76 remaining B-52H bombers with air-launched cruise missiles armed with nuclear warheads. This is part of the broader modernization effort to ensure that the B-52 continues to play a critical role in the U.S. nuclear triad. The B-52's ability to carry a variety of nuclear payloads, including the AGM-86 cruise missile, makes it a key component of America's deterrence strategy. And there you have it, folks. If you found this story of aviation power and resilience as fascinating as we did, make sure to hit that like and make sure to subscribe to the channel. We've got plenty more amazing content lined up just for you. Thanks for watching, and as always, we'll catch you in the next one. Stay tuned, stay curious.